This video will be all about SKActions. To not make it hours long, we won't use and show every single action there is, since there are quite a lot of them. However, you can download a document attached here that has all of the actions listed with a brief description of what they do. So if you want to experiment with them, you should really do so. We will use some of the more important ones here and test how they work and what we are able to do with them. To be able to test easily within our game scene, we want to add one more method to the class, and that is the touchesBegin method. This method exists in the SKScene base class, so we will have to override it here. I can just begin typing its name, and as soon as it pops up, I can just hit enter and it gets implemented correctly. This method gets called as soon as a tap on a screen is registered, or with the simulator here, as soon as we click on the screen. We want to use this as the trigger to run our actions, so we can easily observe what happens. The first action we are going to try is moving our spaceship to the top right corner of the red box, starting from its current position. To actually execute an action, we have to call the run method on the node that we want to run the action on. So I'm going to write my first textured sprite node.run, and if I select the method, I can already see that it will accept an SKAction as the parameter. And this is the action that will be executed. I can add the action by typing SKAction dot, and then I can choose from all of the actions provided by the SKAction class, which are again quite a lot. Like I said, we put them all in the document available for download here, so if you are interested in the functionality, you can just download this file and read up. We do now want to choose this one, move to, which will move the node to a certain position we will define as a CG point over a certain period of time that we can also specify. So let's select it and start by defining a new CG point and the X value we're going to use my first sprite node .size.width, and for the Y value my first sprite node .size.height. Since this is the top right point of our red box where we want to move our spaceship to, I will set the duration to 2.0, which means 2 seconds. And that's it for our first action. What we will do is move my first textured sprite node to this position over 2 seconds. The trigger for the action will be a tap on the screen. So let's run the app and test it. Visually, nothing has changed in our app, but as soon as I click on the screen, we can observe our spaceship moving across the red box for 2 seconds, until it arrives at the top. If I click again, nothing seems to happen. But that's not true. The action actually gets executed again, but since we are already in position, nothing happens on the screen. We can now stop the app again and add another action, this time to our blue box. So let's write bluebox.runAction and define a new SKAction dot, and here I want to choose rotate by angle. This action rotates our sprite node by a certain angle that we will define in radians. It must be a CG float, which is the floating point number type of the core graphics framework. So let's cast it right away and in the parentheses write m_pi. This is the constant for pi, which will rotate our sprite node halfway clockwise. The duration will also be 2.0, and we can then run the app again to see both actions live. As soon as I tap, the spaceship moves and our blue box rotates. The rotate action can of course always be observed. So if I click again, it rotates again. I can already create some funny behavior if I click multiple times, because the actions stack up and rotate our box much faster. However, 2 seconds after my last click, it will stand still again. The next thing we are going to look at are actions with completion handlers. These actions can specify certain code that will be executed as soon as the action is over. In our case here, for example, after the 2 seconds ran out. It would be nice for our spaceship, for example, if we could just reset its position after the movement, so we can run the action again and see it again. So let's stop the app, and I will just comment the line we have for the spaceship so far. Instead, I will run a new action on the sprite node, and this time I will not use the simple run method, but the run method with the completion handler. The action will be exactly the same one, so I can actually just copy it from our original line and paste it here. If I now go to the completion handler and hit enter, I get a closure block that will get executed as soon as the action is over. I simply want to reset our position here, so what I will do is my first textured sprite node.position and set it to a cgPoint.0. However, this will give me an error, but don't worry. All that's wrong here is that we are in an encapsulated block, which will not automatically recognize my first textured sprite node as the property of our game scene. We can easily fix this by simply writing self dot in front of it to explicitly declare that we are in fact talking about the property sprite node and get rid of the error this way. We can then run the app again, and now, since we are going to reset our position, we should be able to execute our move action multiple times as well. So let's tap, and we can see that the spaceship just jumps back after the action is done. The next thing we want to change is the action for our blue box. So to start, we are going to comment the current action, since we want to change it in a way that it never stops. So it will be repeated infinitely, and the box always rotates as soon as we start the action. To achieve this, we can use a repeat action by writing bluebox.runAction, and I will now encapsulate the original action, which gives us the rotation in another action, and that will be SKActions.repeat forever. I can already see here that this action takes a parameter of type SKAction, since we must specify what actually should be repeated. This action will be our old rotate action, so we can just copy the action from above and paste it in here as a parameter. If we now run it, rotate action should never stop. As soon as I tap, the spaceship does its old movement pattern by gliding across and being reset, and then stops. Our blue box, however, keeps rotating now. I can accelerate the rotation by again clicking multiple times, and this time the actions will stack up and never stop, so we can really get to a very fast rotating velocity. What would be interesting now is how we can remove actions from sprite nodes if we decide that we don't need them anymore. For example, if we want to stop the rotation of our blue box right here. To achieve this, we will now begin by checking for running actions on a node, and if so, stopping them. Or better yet, removing them. We will now put our line for the blue box here inside of an if statement by checking if blue box dot has actions, and only in this case called run actions on the box. This simply checks if blue box is not already running an action at the moment, and if so, we run our rotate action. In the else part, we're going to write blue box dot remove all actions. This will simply remove all currently running actions from the blue box. Again, let's run the app and see if it works. We should now be able to start the action and stop it again by clicking. Our first click gives us the normal rotation, just like we had before. If I click again, the spaceship actions runs again, and our blue box action is removed, so the rotation stops. We can already observe a behavior that is important. So keep in mind, our box stops at exactly the rotation it has by the time of us stopping it. Meaning the box does not reset its rotation or its position, but keeps the performed changes up until this frame. For example, like this. It is important to know that when working with actions, since it can lead to unexpected situations if we do not manually reset some of the actions properly. If you remember from our introduction, we have some other actions that can include other actions. For example, sequence and group. Sequence will run its child actions one after another, and group action will run its child actions all at the same time. Let's have a look at this using our blue box by commenting the line, the action so far, and instead write blue box.run action and specify SKAction.group. Here we will have to pass an array of SKActions. For the first one, I will just copy our rotate action again, and then just paste it in the square brackets of the array, and then after a comma define a second action. This one will be SKAction.scale by, and we're going to give it the values 0.9 and the duration 1.0. This will rotate the sprite and at the same time scale it down a little to 90% of its original size. Actually, let's make the duration of the scale action 2.0 as well, so the actions take exactly the same time to perform. But this isn't necessary, it just kind of right now makes more sense to me. I will run the app again, so that we can take a look at what we created. If I click and we pay close attention, we can see the rotation, and at the same time, the sprite node gets slightly smaller. I can repeat it as many times as I like, and the blue box will get smaller every time. The two actions now run completely simultaneously, so after 2 seconds each time, they are finished. Now let's take a look at how this would work as a sequence. So one action after another. Again, we will comment the existing line and instead write blue box.run action, and this time it will be an SKAction sequence, which, just like the group, will accept an array of SKActions. To keep it simple, I will just copy our array from the group that we just used, and now it will do the same exact thing. However, this time it won't be simultaneously, but one action at a time. So we rotate the sprite node and then scale it. So let's have a look. We can clearly see the rotation of our box, and after the rotation is finished, we can watch it shrink down a little bit and perform the scale action. Actions as a sequence always start as soon as the previous action finishes. And they can have completely different durations in sequences as well as in groups. I will now use a multi-line comment to comment all of the code that we've written in the touches began method so far. And we will then have a look at the last special kind of actions, and these are the actions that are given a key on creation, which we can then use to refer these specific actions and, for example, remove them. So let's do my first textured sprite node dot run action, and we can see that we have one more option here that says run action with key. I will select this now, and for the action define SKAction.repeat forever to infinitely repeat the specified action. I want to use our rotate action, this time on the spaceship. So let's copy the rotate action from our blue box here and paste it as the child action for our repeat action here. For the key, I must specify a string, so I'm going to use rotation. What this means is that this rotate action now has the key rotation, and I can always use this key to retrieve this exact action and work with it within my code. To do so, I will wrap this line in an if statement again by checking if let underscore is equal to my first textured sprite node.action for key, and then pass the string rotation. If this is true, we actually have this action on the node, and we want to remove it. I can do that by writing my first textured sprite node.remove action for key and simply pass rotation. Else, we don't have the action, and I will add it. So keep the original line that we wrote. I have created the if let statement with an underscore. This just means that I do not need the action itself and just want to check whether it exists. I could use an actual name instead to save the action in it, and then I would be able to remove it like that as well, or maybe change some of its properties. By using the key for our action here, other possibly running actions on our spaceship would not be affected if we call remove action for key. So we can really specifically remove certain actions and not just all running actions from a node. Let's do a final test for the actions and see if everything works. Our first click starts the rotation, and the second click should stop it, since our remove action for key call should remove the action. And that's exactly what happens. I can repeat this as many times as I like, of course. Now we have looked at a lot of different forms and types of actions, with normal actions, actions with completion handlers or keys, repeat actions, group and sequence actions. Again, I want to remind you that you can download a resource document with all of the actions available in SpriteKit, and I would encourage you to play around with them a little more in our demo project here to see what you can achieve with them. And if you run into any problems or if you have any questions, please feel free to ask us for help. We will do our best to explain more detailed stuff to you personally. Especially for beginners, I cannot stress enough how important it is to experiment and practice with code, since it will make you much more capable and confident with your own coding in the long run.